Dear world, welcome back to the house robbery problem 198 leak code. So today we'll be solving this problem. So first let's study what it tells in the question. So first it tells that suppose you are a professional robber planning to rob house along a street. Each house has a certain amount of money stashed. The only constraint, remember the constant things is always important. The only constraint stopping you from robbing the house is that adjacent house have a security system. It's telling that adjacent house have a security system. So what this means adjacent? Adjacent means every two house. If there is two house, one will have a security system. That means it is having some security. So that is the constraints. So let's start in the next line. And it will automatically contact the police if two houses were broken into on the same night. That means it will contact the police if we break two houses in one night. That means either we can break the first house or the second house. Now given an integer array nums representing the amount of money each house is returned. So this is the numbers. As you can see, this numbers is represent the amount of money. So nums is the amount of number of money. Given an integer array representing the amount of money each house, return the maximum amount of money you can rob tonight without alerting the police. So we have to return the maximum amount of money without informing the police. Maximum amount of money. So guess the point. It is telling that we have to return the maximum amount of money. So what that means, that maximum amount, whenever you get situations like maximum amount, you have to keep in mind one important term, that is optimization. Here it's telling maximum amount of money. So maximum, that means maximum, minimum, greatest, least, these all are the problem of optimization. So from here we have to understand that this is the problem of optimization. That means we can apply here dynamic programming for faster programming. So dynamic programming can be utilized here. So now we will be understanding the concept. What it tells, that if there is two house, suppose let's say the house number 1 2. So if there is two house, we cannot break the two house because there is security system. So we are taking first this number 1 2 3 1, and we are taking another example, this one. Let's say we are taking just 1 2 2 1, or let's change this example 2 1 1 2, because these two are different cases. So now try to understand. It's telling what we have to return the maximum amount, so that if we start from here, if we start from this portion, we have to move to the end portion. So we'll be looking at the end, let's say it end. So we'll be looking that what will be our final, what will be our maximum solution at this position. So there is a constant given that if we rubber from here, that means if we rob from here, if you rob this one, so we can never rob from this, we can never rob, this is the constant given, that it will automatically contact the police if two adjacent houses were robbed. That means we cannot rob from the adjacent houses, so that means we can rob from these houses. So try to understand. So the profit of these houses is 2, and in terms of programming, what we can tell it, that numbers of, if we call it n, we are calling it n, then we will be calling it n minus 2. So that will be the maximum profit, and n minus 2 is the nums value. So this is nums, I mean dp of n minus 2, and this is cost of n. And if we consider this section, look, if we consider this example, so to reach n, if you call it n, so there is two cases that we cannot rob from it, this is clear. So either we can rob from this section, either we can rob from it, or we can rob from it. That is one case. This is a similar case that I made you understand. This is case 1. Now we'll be understanding another case 2. That is, there is, so we are, this is n minus 2. There is one example, this is 2 1, and this is 10 2. So what will you do? Will you be considering this? We can take the value from here, we can rob this house and we can rob this house. So the maximum profit from this house, that will be the value of this cost of n plus the total up to this, because if there are lots of elements, we are considering it n case, that means the last case. So if there are all the elements before, we will fall it inside the function dp, because we always utilize this in dynamic array. So this will be dp of n minus 2. But if, so what will be the profit total if you just consider these four cases? Here the total profit will be 2 plus 1, that means that is 3. And now just try to notice. If we just take this example, if we just instead we don't steal this one, we just steal this section. If we just steal this 10, so what will be the profit? This will be the greatest profit. So we are getting two conditions here, that either this is that will have the maximum profit, and the maximum profit of this section will be dp of n minus 2. That means we'll be robbing up to this area only. So now we got two conditions. So we got two conditions. That first condition was this, that we can, there is two manner we can rob. First manner is that we can rob this nth one, and we can rob this one. So here the rob amount, the total rob amount will be n plus, this n represent the value of this one. So that will be nums of n, that means last elements, plus dp of n minus 2. dp of n minus 2, that means previous sum of all the elements. If there are more like 4, 3, 2, 1, if there are like this, so previous sum of all those elements. So that is, so this is the method 1. We can rob in this way. And the second method I made you understand, that was 2, 2, 1, 10, 2. So if we notice this, here we will not rob this one and this one. Instead we will directly rob this one. Why? Because this is having the maximum. So if we call it n, if we call this one n, we'll be calling this one n minus n. So this is, we will rob for up to the maximum amount with that respect. So that will be dp of n minus 1. Because not only these, if there are more elements before dot dot dot, so we'll be considering all those cases. So the total amount of money we'll be robbing, that will be, we can write like this, dp of n, that will be math dot maximum. Because there is two probability, there is two strategy, and among those two strategies, the one what will return the maximum amount, will choose that one. So it will be dp of n minus 1, dp of n minus 1, comma dp of n minus 2, plus cost of n. So this cost is represented here in terms of nums. So here in program we will be using num in exchange of cost. In exchange of cost we will be using nums. So that is the program that we have to write right now. We'll be writing. So if we generalize this, if we try to generalize this, so what will become? So in generalization, if we just generalize this, it will become something like this. dp of I, we are generalizing this. dp of I, that is equals to math.max. That means we'll be selecting the maximum of dp of I minus 1, comma dp of I minus 2 plus nums of I. For generalization, we just replace the n by I. So this is, now we'll be writing this program in the LeetCode. So we're right now on the LeetCode. I've already written the program, so we'll begin writing. So first things, we'll be starting writing from here. So while we write the program, first we'll be calculating the length, because this is very important in this program. Nums.length. Second, we always need to consider the base cases. Base cases, that means the returning or terminating cases where the program stops in dp. So base cases in dp is first cases will be check length. If the length is 0, that means there is no house. In that case, we'll be just return 0. Second, you will be checking if n equals to 1. If the value of n equals to 1, that means there is only one house. So we'll be returning the cost of that house. Return nums of 0, because 0th index is 1 is represented by 0th index. So these are base cases. Now we'll be initializing a dynamic programming array to store the sum of all houses one by one. So for that, dp array initialization, integer dp, that is equals to new integer n. Now dp of 0, that means the nums of 0. because this is the still amount of first house, that is the still amount of first house, and dp of 1, that will be the still amount of second house. So in second house we can steal the second house in two way, either first either two, the first one or the second one. So in this case we will be selecting the maximum one, math.max nums of 0 comma nums of 1. So this is the way. So this is for 0 and 1, and now we'll be generalizing for n terms. So we'll be using the formula that I just shown you right now. This we'll be just utilizing this formula. I just made you understand this one. So we'll be writing this one without utilizing any more brain. So this one will be started. Okay. So here we have calculated for the first zeroth and the first one. Now we'll be starting from second index. For I equals to 2, I less than n, I plus plus. And now we'll be just writing dp of I, that is equals to math.max of dp of I minus 2 or dp of I minus 1 plus no, that was not the case. The case was dp of I minus 1 or dp of I minus 2. So we have to write that one. We just made a typing mistake. So first this will be dpi of I minus 1. Either we are selecting this one or we are selecting the dp of I minus 2 and the dp, that is cost of nums of n. So it will return as the maximum one. Now we'll be return dp of n minus 1. Okay, now we'll be running the program. Let's see if it works or not. We initialize as an error. We also have to generalize this. We just made that mistake. So now we are submitting. Okay, our program got submitted. So you understand all the things, that it was very easy program. We just generalize that one and we utilize the same formula at the main. So first things in DP that we have to understand the program. Then after understanding the program, we have to generalize the entire program. First we understood that was the case 1 and then this was case 2, and we combined this method here. So this was all about DP. We'll be meeting in the next